kids. The YDS experiment demonstrates that there what happen, it will behave like a wave. So like that what happen, it all depends upon the situation, or you can say chance. It all depends upon the physical conditions. The light will exhibit either wave nature or particle nature. In YDS what happened, the wave nature came into picture. In photoelectric effect, the particle nature into came picture. It all depends upon the physical conditions what we create. The light will exhibit that particular property, either particle or wave nature. Similarly, the matter also, depending upon the physical conditions what are available, it will exhibit either the wave nature or particle nature. So matter means, what is matter? Sir, laptop, yes, it's a matter. Yourself, your body is a matter. Myself matter. Electron is a matter. So altogether now, de Broglie matter waves. What is proposed de Broglie hypothesis? The universe is made up of matter and radiation. That's all. What all this universe is there? Matter and radiation, and that is what we say. The dissolution of dissolving of universe, creation, Big Bang theory. No, so prior to matter, what happened? It was only radiation. Then the radiation got converted into matter. Then now what happened? So we are in the stage of matter. After one time, what happened? Again, this whole matter will be condensed and will convert into radiation. Then again, one finally what happened? The radiation will get converted, a part of that converted into matter, and the creation begins. Universe, life of the universe will begin. So therefore, the de Broglie matter waves further helped to understand that Big Bang theory. Okay, let's come to the main concept. So is I'm a matter? The pen, notebook as a matter. So now if we just take a stone, or take example cricket ball, is it a particle or wave nature? What you see? We see particle nature. What all visible for our eyes is what? Only the particle nature. The matter itself is visible. Then you throw the ball. So when you throw the ball open, as the ball starts moving, as it acquires momentum, then a matter waves are associated. But sir, I don't see that. Okay, what is the value of h? 10 to power of minus 34. Leave that 6.63. 10 to the power of minus 34. Mass of the cricket ball, let it be 1 kg. Velocity, let it be 100. Then what is the lambda associated? Will be of very small wavelength. No? And hardly we can notice. Our human eye cannot resolve that. That's why we're unable to see that matter waves. Please try to, it's a purely imaginary subject. I'm just trying to bring order. Cricket ball. Mass, let it be 1 kg. It is projected with a velocity, say 10 meter per second. Look at the lambda, 10 to the power of minus 33. Can we resolve such a wavelength? Not possible, no? The human eye cannot resolve this wavelength. Am I right? That's why we're unable to see. Finish. Simple example. Maybe, sir, they're invisible. So so why we can't have any instrument which can detect matter waves? The instrument weapon should have resolving power of such a thing. So when you go to optical instrument, you can see that one. So instrument of this order weapon very difficult to construct, which can resolve. Means 2 points separated by such a distance. Can we say that the 2 points, I'm able to see 2 points? Anybody having such eyes? Means I'll draw 2 points, I'll place, and the distance of separation between them is 10 to the power minus. Can you say still 2 points? No, you say hardly you say any point here, because you look at the separation. I think the distances of order of 10 to the power of minus 10, only a few millimeter we can see, no, 0.1 millimeter as we are able to see to some extent. Micrometer, nanometer, and this will come of very small distance. No, can we notice 2 points separated by such a distance? Forget about distance, we can't see that point itself. The human eye cannot resolve. That's the thing. So then matter waves exist here. Now if it is projected with kinetic energy, then 2m into k. This word books like a on the based on formula. So then what is the kinetic energy? Yes, based on kinetic energy also we can express the matter waves. Where do that matter waves are? How do they will be? How do they will be? So let's get into YDSA experiment, because they're the one practically which we are able to see this. Even nowadays for iodine I think is not a some sort of electron, no. For even iodine molecules, a beam consisting of iodine molecules, what happen if I accelerate it, if I push it and if I pass through YDS, I can see the iodine molecules, what happen, getting diffracted. So iodine is not something like a not lighter particle considered to be heavy, no. So maybe in future what happen for cricket balls, we can show this diffraction and YDSC. Okay, let's begin with the theoretical analysis here. Okay, this is a screen. No, let me send an electron beam. What is the incident? We are going to send an electron beam. Now, what do you expect? You don't know anything about matter waves. So according to our perception, so electron beam is, I'll show like this. It's having definite mass, no? Are we able to measure mass? Yes. So is it electron particle? Yes, it's a very much particle. This is the electron beam. It is having velocity, so it is having some momentum. Now, what will happen to these electrons when they press? According to the perception, what we know, according to the physics, what we know, what we say, this will strike, these electrons will come and strike here, and these electrons will come in. And let me put this as fluorescent screen, fluorescence, phosphor layer. I'll take some cardboard, something. I'll put phosphor on it, phosphor nitrate, this one. So there's a phosphorus nitrate. I'll paste on it here. Now these electrons or pen will strike it. So according to the the physics, what we know. So what we see. So we can just, shall we put that one? We'll see only bright spots or the fluorescence only at 2 points. The electrons will travel along this straight line and they'll strike at point P1 and P2. Of course, if you make the width of the slit, no, so some electrons will come here. So let me just take a narrow slit. Let me take it. So shall we say that we'll see fluorescence? What do you mean by fluorescence? Fast moving electrons, if they strike some any surface, so what will happen to it? It will give out its kinetic energy, and that kinetic energy will be absorbed by the phosphorus nitrate molecule, and the molecule will jump to the higher state. When it jumps from higher, again when it make transition from higher to lower state, it will give out photons, and that photons is what we see light. Depending upon the type of material, the different colors will come. Where we used earlier LCD screens before LED, LCD. In LCD screen, this was the method, no? The old televisions, the fast moving electron beam used to strike the part of a screen, and due to that screen, what happened? The light used to get displayed. So now we are coming for LED technology, the phones, everything, that one. Let's come for this. Where do we can see? So we can see fluorescence at point P1, P2. Is it okay? Shall I use word fluorescence? Means we see is light. We see that light, some sort of spark will come. Sir, what do you mean by fluorescence? Deepavali, some pencil, we should not call cracker, no? So when you lit it, you'll get some sort of here, light here, no? Sparklings. This call like a, I don't know Telugu what you call, sparkles, no? This will be. So a kid will hold at this and he'll get sparkles. So like that, what happen? We'll get here sparkles here. Or fluorescence, what we notice. Scientifically, fluorescence or not understanding sparkles. So we'll get here this one. Only here. Yes, according to the physics, what we say is only here. But practically, what happens when I send electron beam, I don't see only at point P1, P2. I'll see everywhere. At one point, I don't see any fluorescence. At one point, I'll see maximum, and the sparkling keeps on decreases. It is similar to the YDSC pattern. So how you are bringing YDSC here? Where is the light? The electron beam is similar to light. It will behave like a wave. So what we notice is that we see sparkle here. Then again, no sparkle. Then again, this one. So means here, this region, more number of electrons come and strike here. What about here? No electrons reach in this region. So is it practically happens as we are able to do? See, like some when de Broglie proposed, we didn't have the equipment which will generate that electron beam and passing through YDSC. But now we have equipments. We do have equipments here. I think in one of the website I have seen. So like that sparkles they were showing that one electron beam, that particular thing they're showing that one. So you have to search. It's not there in YouTube, but in one of the website it's available. It will be like this. So how is this possible? The electron behaves like a wave. Pretty sure. So can we calculate the maxima, minima, all everything? So what is lambda here? This particular electron beam, they're moving with a velocity v. They're having a mass. All electrons will have a velocity v, and they're having a mass. So what is the wavelength associated with the matter waves associated with this one? This VE I'll call. What is VE? Speed of electrons. Then how to get the maxima? N lambda capital D by D. So this is the distance D and this is capital D. So how to locate the positions where the electrons will come and strike the screen given by this one. So N D by small d. What is lambda? Lambda is H by ME into VE. So that I am replacing it. So NH capital D by small d ME into V. Or I'll write it here. It'll be in proper order. This will be the position of electrons where they'll come and strike it. Maxima. I'm just telling you, we know that similar to YDC here, because here the maximum number of electrons will strike here. And as you move, the number of electrons striking the screen will decrease. And somewhere at the midpoint of dark band will be zero. No electrons will be striking. So I am just saying no electrons. I think it is just in a lighter manner, you should understand that at the midpoint of this region, there won't be any electrons striking. Okay, next question comes. So like which electron will reach here? Which electron will reach here? So I'll give the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So which electron will reach here? 1, 2, 3, 4, 5, 6. We are not the science what we know, even the quantum mechanics what we know, we are not sure which electron, what makes this electron to come here, what makes this electron to go there, we are not sure. So which electron will come and strike on the which part of the screen, what happened we don't, and what makes this electron to come till here, and what makes this electron, maybe the electron 4 will strike here, the electron 5 will strike here. How come, sir, like both are having same mass, same velocity? I think this is something totally the way what we know the science till now. So definitely what happened, there is something is there. The nature, what it behaves, the way it behaves like a wave. And this you may not accept. This is experiment. A good example, like when you go for theater, once the movie gets over, people will rush out, no? The persons who are rushing out, how they will move? They'll spread, no? They'll spread. So I think, Feynman's lecturer, he just said that we also behave like a wave. When do we behave? when you ask 100 persons to come out certain door, one single door, then what when the persons what when all will not come straight, they will spread. No, any reason? Because the situation made us to behave like a wave. The situation made us to behave like a, the same thing here. Now I'll remove this slit. I'll remove this slit. So total this slit I'll remove. Tell me what will happen. These electrons will strike here, 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 these electrons will strike. How do they behaving? Particle. When you bring this slits, they'll behave like a wave. So tell me like the matter whether it will behave like a wave or particle will determine the physical conditions. That's all. Nothing else is there. And now like a next question comes. So we'll do one thing. I will send two electrons instead of this. Let me send two electrons. So can we say that which electron will come in where it will strike? So we are lucky enough that we are in 21st century and studying this. If this I were teaching in 1960s, 70s, no, there's no other way. Just what happened? This formula and okay, sir, finish over. It will be there. It is existing, that one. Luckily, we are in 25. In 1989, they demonstrated with iodine molecule. I think somewhere in the 19 like a 70s, what happened with electron? They're able to do with electron beam. In 1989, I think so. Around that one with iodine molecule, they were able to do this. So now what will happen? We are able to even isolate a photon, one photon, two photons. We are able to isolate, and they're doing experiment that. So one isolated photon also, we are able to do the experiment here. Now only one electron, I'll send it. This electron, where it will strike the screen? Anywhere on the screen. If it were particle, definitely it will strike, no? Since it behave like a wave, so it will strike anywhere here. I'll remove this slit. It goes straight and strike it. So therefore, whether a matter, it will behave like a particle or a wave, again, it depends on the situation. The same thing with the light also. The light, when you pass through a YDSC slits, it will behave like a wave. When you make it to incident on a surface, on a metal, it will behave like a particle. So what makes the light to behave like a either wave or particle? The physical condition. Similarly, same thing with the matter also. Now, why we are behaving like a particle? Why you are seeing my body like this, physical body? Since the physical conditions are so such that you are able to see my physical body. If you create a conditions in such a way that, then what when if I'll exhibit my wave nature, then if you're able to see that, yes. So it all depends upon the physical condition also. Means, sir, in future, can we see the matter waves exhibited by us as maybe the instrument if we design? So what the some of the journals they're telling, there are some species that are there in aquatic animals. They don't have vision. They don't like a they don't have anything. Only for matter waves they respond. That's what I think in 1998 in one of the science journal they have like a published it. That one there are some aquatic animals are there. They don't respond for the sonar. Sonar means sound wave, and they don't have like a light. This one they don't have eyes. If they don't have eyes means no question of responding for electromagnetic wave. No, the next thing is sound waves, because I think some most of the species, fishes, no, some species will not have eyes. By sound waves only, what will happen? So by say like a by sonic boom or say by sound waves only, what happen? They will estimate the object, food, everything. And there are some aquatic animals are there where they don't respond for sound, they don't respond for thermal radiation, they don't respond for electromagnetic wave. Then how do they search food? Then when they searched it, no, they were like a making a guess of matter waves exhibited by that aquatic food. Because any aquatic food, what happen due to some, it will have vibrations. So that particular algae or fungi, what happen when it starts moving, some matter will be associated, and they are so sensitive that with that matter waves, they're able to make a guess of a food. They're tiny particles, not like a crab or prawn, fish like that. That tiny, that one. So similar to like some amoeba, they say like one microscopic bacteria, you can better put it. They're responding for what? They're responding for matter waves. That's what the science is now checking for, the different types of bacteria and virus. Means how do they communicate? What makes the virus to that one? So that's for the coronavirus. No, the research is going on. Means how do that COVID-19 virus what will communicate with other virus? What makes it signals to that one? Of course, we say that it's just a RNA material, but what makes that RNA material to multiply? There should be some sort of intelligence should be there. How do that will happen? So that's what I think. So we do have some bacteria, or better you can call virus. I don't. So bacteria or virus, some is like a aquatic microscopic creatures which will live at the bottom of the sea or in the sea. They will respond for matter waves. Therefore, the 1998 it was done. 80% accepted, remaining 20% they asked to show proof. The proofs what when few accepted, few didn't accept it due to some anomalies. That one. So definitely what when there are some creatures are there who will respond for matter waves. That much what we can conclude here. So maybe in future we may get detectors which will detect matter waves. I think this will be, and matter waves, sir, matter waves, how they will be, way to find out that matter waves nearby that object. Suppose a part, if I'm there, I'm moving, then where the matter waves nearby object, what is the probability of finding matter waves nearby object? It will be more. And till where? Till infinity. The matter waves open from where to where? From the uh, where the particle is there nearby that particle to till infinity they'll be spread it. So don't try to assume matter waves of like this, and don't try to assume the wavefront also. Don't assume any wavefront, nothing. So we should not bring the idea of wavefront for matter waves. So they're the matter waves. So in books open they show like this, some. And this particular thing will extend till where? Till infinity. If I'm here, what will happen? The peak will be maximum. This show that I'm here. And also European, the matter waves open will spread till infinity here. So I think the waves what when we assume should not be thought like that. There's a total, if not have any wavefront, nothing. Now, sir, I'll move it. Yes, the matter wave also will propagate here. Then what is the speed of matter wave? Next question comes. So what should be the speed of matter wave? Means like as we move, the matter wave also propagate here. So what should be the speed of the matter wave? So let's get expression for the speed of matter waves here. Can we bring expression for speed of matter? Because we know momentum. What we know is only lambda, no? That formula, what we know it. After that, we don't know anything. So how to bring the expression for speed of matter waves? I'll just have a water. Okay, no, we'll go for the getting the matter waves will propagate. Huh? It's not that there'll be. So we know lambda equal to h by mv. Then this will be h equal to f equal to v by lambda. There's a from wave equation I brought it. Frequency equal to v by lambda. Then we know E equal to mc square. Shall we adjust all these things? So this v will write it as f into lambda. Lambda is what? H by mv. And what is F we can write? And E equal to HF. So F equal to mc square by h. So F will be mc square by h, and lambda is h by mv. This is the group velocity. We'll put it here. What is V? V is this is the object of mass m moving with a velocity v. And what is Vp? That is called like the speed with which matter wave propagates. Better say particle. So look at the matter waves. They'll propagate with a velocity more than the speed of light. I think don't go for, again we have phase velocity, group velocity. So it's some not needed at our level. So possibility of asking the speed of matter waves c square by v. What is v? V is the speed of object. Okay, no. So this is about. So now if I send only one electron, tell me where do it will strike? Anywhere on the screen. No? If you remove this slit, straight away here. If you send one photon, also same thing. The photon may strike here, 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 anything. If you remove this particular slit, it will likely strike here. So definitely open. So shall I say that it all that physical conditions will make the even the matter to exhibit whether wave nature or particle nature. Since we are not put any constraints, so what way we are exhibiting particle nature. If you put any physical conditions on us, then what we may start exhibiting wave nature. But don't think that the electron now what will happen? I'll remove this slit. Electron moving with a speed. Will it have any matter waves? Yes, it will be there. It will be there. Huh? It will have matter waves. Then when you bring this slit, then also it will have matter waves here. So don't think that again the matter waves will eliminate. If any matter, any body which is having momentum, it will have matter waves here. To show that even the matter will behave like a wave, this YDA experiment is what I brought it. So shall I say YDAC is what will put a condition for this electron to behave like a particle or a wave. If you remove slit, particle. If you bring these slits, it will become like a wave. To show that matter waves do exist, I'm taking this example. So able to get this one. So now there can be a question for you like this. If I increase the if I increase the speed of the electron, if I increase the speed of this incident electron beam, the speed of electrons if I increase, tell me what happened to Y max will decrease, no? What will happen to fringe width? Will decrease. So we don't see we don't see like this, huh? Just it's a theoretical one. Of course, we see some spreading that one. We see spreading here. So since you don't know diffraction, so actually if you see the electron beam, only one hole. So even for YDSC we do it. So practically what will happen? I'll send an electron beam. Then what I notice is that I'll see the electrons will strike in this region. If it were really if the electron were behaving like this slit, if electron were behaving like a particle, we would have seen only in this region electron. What about here? The probability of searching electron is everywhere here. Electrons, again curve. I'll do one thing, some region in which electrons can exist. If it is a particle, then I would have just seen only in this region, but I see this. So they show that get deflected. Ah, sorry, it is getting deflected. Maybe there is a weight, magnify. No, nothing is there. Just a narrow slit is there. So it gets diffracted. Even the electron beam gets diffracted. It's a very popular experiment. I think this there in YouTube. We can't see electrons. I think you know that one. Only we can see fluorescence. So in this range, I'll keep a detector. The detector can detect the incident electrons in this region. We can't see this peak. This is only graphical interpretation. I'm making things clear. You don't see this curve. You can see just electrons stacking in this region. If I paste a fluorescent material, I can see in this region. As you narrow the slit, then definitely open, you can see electrons reaching here also. So this is about the interaction part. Tomorrow we'll explore further these things. Okay, thank you all of you.